Welcome to AskPrep, your trusted companion for NEET and G preparation. Today we will study about a very important topic of physics, which is Kinetic Theory of Gases, Ideal Gas Equation. In this video, we will delve into the kinetic theory of gases and the ideal gas equation, fundamental concepts in understanding the behavior of gases. Understanding the kinetic theory and its applications will help you understand how gases behave at the molecular level, and it's vital for solving many physics problems. Let's start by discussing the kinetic theory of gases. The kinetic theory provides a molecular-level explanation of gas behavior. It is based on the assumption that gases consist of a large number of very small particles, atoms or molecules, that are in constant random motion. These particles move in straight lines until they collide with each other or the walls of the container. The collisions are perfectly elastic, meaning that there is no loss of kinetic energy during the collision. One of the fundamental assumptions of the kinetic theory is that the size of the gas molecules is negligible compared to the distances between them. This means that the gas molecules themselves do not occupy significant volume. Another key assumption is that there are no attractive or repulsive forces between the gas molecules. This is a simplification, but it works well for many gases under typical conditions. The temperature of the gas is a measure of the average kinetic energy of the gas molecules. As the temperature increases, the molecules move faster, and their kinetic energy increases. This relationship between temperature and kinetic energy is essential to understanding gas behavior. The average kinetic energy of a gas molecule is directly proportional to the temperature of the gas, and this is expressed by the equation K_Vg is equal to 3/2 kT, where K_Vg is the average kinetic energy of a gas molecule, K is the Boltzmann constant, and T is the temperature in Kelvin. This equation tells us that the higher the temperature of the gas, the higher the average kinetic energy of the molecules. This is why gases expand when heated and contract when cooled, as the molecules move more rapidly and collide with the walls of the container with greater force when the temperature increases. Next, we will look at the ideal gas equation, which is a mathematical relationship that describes the behavior of an ideal gas. The ideal gas equation combines several relationships between pressure, volume, temperature, and the number of particles in a gas into one equation. It is expressed as PV is equal to nRT, where P is the pressure of the gas, V is the volume of the gas, N is the number of moles of gas, R is the ideal gas constant, and T is the temperature in Kelvin. The ideal gas equation is an approximation that assumes the gas molecules do not interact with each other except during elastic collisions, and that the volume of the molecules themselves is negligible. This approximation works well for many gases at high temperatures and low pressures. However, at very high pressures or low temperatures, real gases deviate from ideal behavior due to intermolecular forces and the volume occupied by the gas molecules. Let's break down the components of the ideal gas equation further. Pressure, P, is the force exerted by the gas molecules when they collide with the walls of the container. It is typically measured in pascals, Pa, or atmospheres, atm. Volume, V, refers to the space occupied by the gas. This is usually measured in liters, L, or cubic meters, m superscript 3. Temperature, T, is the measure of the average kinetic energy of the molecules and must be expressed in Kelvin for the ideal gas equation to work correctly. Remember that the Kelvin scale starts at absolute 0, 0 K, where molecular motion ceases. Number of moles, N, refers to the quantity of gas present in the system. 1 mole corresponds to 6.022 x 10 superscript 2 superscript 3 molecules, a constant known as Avogadro's number. The ideal gas constant, R, is a proportionality constant in the equation. Its value is 8.314 J, mole point K, when pressure is in pascals and volume in cubic meters. When pressure is in atmospheres and volume in liters, R is 0.0821 L.atm, mole point K. Now that we know the ideal gas equation, we can use it to solve a variety of problems related to gases. For instance, if you know the pressure, volume, and temperature of a gas, you can use the equation to calculate the number of moles of gas present. Similarly, if you have the number of moles and temperature, you can determine the volume or pressure of the gas. Boyle's law states that the pressure of a gas is inversely proportional to its volume when the temperature and the number of moles of gas are held constant. Mathematically, this is expressed as PV is equal to PV. This means that if you decrease the volume of a gas, the pressure will increase, provided the temperature and the number of gas molecules remain unchanged. Charles' law states that the volume of a gas is directly proportional to its temperature when the pressure and the number of moles are constant. This can be written as Vt is equal to Vt. This implies that if the temperature of a gas increases, its volume will also increase, assuming pressure and moles of gas are constant. Avogadro's law states that the volume of a gas is directly proportional to the number of moles of gas when the pressure and temperature are constant. This is expressed as Vn is equal to Vn. In other words, if the amount of gas increases, the volume will increase, provided the temperature and pressure remain constant. These laws help us understand the relationships between pressure, volume, temperature, and the number of gas molecules, and they are all consistent with the principles of the kinetic theory of gases. In conclusion, the kinetic theory of gases gives us a deeper understanding of the behavior of gas molecules at the molecular level, and the ideal gas equation provides a powerful tool for calculating properties of gases. These concepts are central to many areas of physics and are essential for solving problems in thermodynamics, particularly for the NEET exam. Understanding how gases behave under different conditions will not only help you with your exams but also give you insight into the physical world around you. Thank you for watching this video on the kinetic theory of gases and the ideal gas equation, brought to you by AskPrep. Thank you. This is AskPrep, your guide to mastering NEET preparation. Let's decode complex topics and simplify your journey to success.